let's look at this final problem. Compare the reactor volume required to achieve 95% efficiency. So we need to do a comparison. We want to get 95. We need to get 95% efficiency for a CMFR and a black flow reactor for the following conditions. So we have two scenarios. CMFR or black flow reactor. Steady state, assuming steady state, and first order reaction. The flow rate is 14 meter cubic. This is meter cubic, should not be here. 14 meter cubic per day. And reaction rate coefficient is 0.05 per day. So we have flow rate 14 meter cubic per day, and we have reaction rate coefficient K is 0.05 per day. So we will compare these two reactors. Now the efficiency is 95%. So remember, if you took statistics, how to find the efficiency is by dividing. If you have, let's say, if you have concentration initial, and let's say concentration N and concentration out. So this is the final and this is the initial. So if you want to find out the efficiency, let's just make this as efficiency. It is initial minus N out over N initial times 100. Okay, so this is the efficiency of the performance of CMFR or black flow reactor. So what we're going to do here, we will do it like this. The efficiency is equal C initial minus C out over C initial. Okay, don't worry about the 100% for now. N is not 95%, it's 95 over 100, which is 0.95. So this is equal 0.95. If I divide this Ci over Ci and divide every one over Ci, it will be like this. Ci over Ci minus C naught over Ci over Ci over Ci. So everything is divided by Ci. So this is 1 and this is 1. So it will be like this, 0.95 equal 1 minus C naught over Ci over 1, which is equivalent to this. Rearrange the equation, C naught over Ci is equal 0.05. Now let's go for the CMFR equation. This is, we will use this in our equation to see the performance. Let's look for the CMFR. Remember the equation that we studied in class. dDc over dt. He said it is steady state. So this is 0. QCI, flow rate times concentration initial, minus QC out minus volume K C naught or C out. So this is for first order reaction. Of course, it is when you do it C to the power 1, that's first order. If it is 0 order, it's going to be C to the power 0, so the C is all done. Okay, so now it is first order, so you're going to leave the C to the power 1, so leave it as is. Now we have the flow rate 14, so we have the flow rate here 14. Ci is unknown, minus 14, the flow rate did not change. Remember for CMFR, this is the tank, flow rate N, flow rate out, they are equal. Q out, Qn is equal. This is for a CMFR assumption. So 14 times C out minus volume is unknown, K is 0.05, C out or C naught. Now rearrange the equation, you will get C out and volume and Cn. Well, we're going to bring this equation back from here. C out is equal 0.05 Cn. Now, we will go to the C out and replace it with Ci. So you'll have it like this, 14 Ci minus 14 times 0.05 Ci minus 0.05 volume 0.05 Ci. From the equation, you could notice that the Ci will cancel with the Ci, will cancel with the Ci because it's equal to 0. You'll end up with a volume of 5,320 meter cube. So this is the volume for the CMFR, for CMFR tank. Now for the black flow reactor, we're going to use the famous equation for the black flow reactor. C out, or C final, is equal C initial, e to the power minus kT. Let's take the C out over Cn equal e to the power minus kT. And C out over Cn, we have it here, is equal 0.05. E to the power minus 0.05, K is given, times T, and then you will do ln 0.05, and then equal minus 0.05 T, you take the E out, and then 2.996 equal 0.05 T, you will end up with a time of 59.9. Let's find the volume. The volume is equal to what? Remember, the volume is what we're looking for. So the volume now is equal, Q is meter cubic per day times the time, day, and then you'll end up with meter cube. So if you multiply the time times the flow, you will get 838.8 meter cube. So now we know that the CMFR could treat as much as 5,320 meter cube. This is a good reactor. While the black flow reactor will treat only 838.8 meter cube of wastewater. So this is for black flow reactor. So you could treat as much or high quantity of wastewater in the CMFR to make it efficient in only volume. Okay? So if we are getting the same volume, you can see that the CMFR is really good in treating too much volume of wastewater, and it's more efficient.